702.
The Naked Scientist.
It's that time, the Naked Scientist, Dr. Chris Smith. Give us a call, 011-883-0702, if you want to ask the doctor any of the science-related questions you have, or send through a WhatsApp, 072-702-1702. Doctor, happy Monday.
Happy Monday. How are you?
A lot going on in your world.
Yeah, it's very, very busy. Obviously, we've had to change a few things, and the mood is quite muted at the moment. But on the whole, people are regarding this as a celebration of Queen Elizabeth II's life, not a mourning. Her official funeral is going to be on Monday next week, which will become a bank holiday. So I'll be talking to you next week from the day when she's actually being laid to rest. So it'd be interesting to see what's happened in the meantime.
So would you then say, are people taking that bank holiday to observe and try and be a part of proceedings? Because I saw so many people gathered, when Prince Harry and William were there with their wives greeting. Is it something that people are quite invested in?
Well, I think people are also very aware of the historical significance. For many people, they have lived their entire life with Queen Elizabeth II being the reigning monarch. And so what they're seeing all in the flash is that person being laid to rest, her son being the king, and we now have a king of the country again rather than a queen of the country. And so this is the kind of thing that people are not going to see very often. In some cases, they're only going to see once. And so I think people are really interested in this ceremony, in the tradition, because my wife remarked to me the other day, she watched the investment of Prince Charles becoming king, officially being appointed as king and giving his acceptance speech, etc. And she said it was really interesting seeing the tradition and the very old-fashioned English and the very old-fashioned approach to how this was done. And it's just an amazing glimpse and insight into history, because this hasn't happened in the last couple of thousand years very many times, really. And so to have the opportunity to see this and to be part of it, it's history in the making. And I think people respect that, and they want to be part of it.
All right, well, we'll be getting a lowdown from you on Monday on what the energy is like where you are. For now, let's jump into all of your calls and your WhatsApp messages and questions for Dr. Chris Smith. Poloso in Centurion, hi.
Hi, Relebogile and Dr. Chris. Good show as always.
Thank you.
I want to know the difference between 95 and 93 octane, whether you can use them interchangeably, and also if you mix them, what's going to happen?
The octane level of fuel, it's a slight misnomer. They started using this word octane a while back in history, but they've stuck with it just by convention. But what it refers to is the ability of the fuel to resist pre-ignition. If you put petrol into an engine that's got very high compression, then if you're not careful, the fuel will detonate too soon, because normally it needs a spark from the spark plug to start it burning. And if it goes too early, it causes this thing called knocking or pinking. In other words, the piston is still compressing the gas in the cylinder when it's trying to burn and expand, and this can cause damage in the long term. So we try to tailor the timing of engines and the appropriate fuel that goes in that engine, which has got the right characteristics, the right compressibility, so that does not happen. And some engines are set up to take certain fuels in certain ways, and some old-fashioned engines will not tolerate more modern fuels. Also, you can have different additives in fuels that affect that so-called octane rating, which delivers more oomph from the fuel. You get better performance because it burns better, it can withstand more compression before it starts to burn and so on. So it will really come down to what the manufacturer recommends for your car. Now, that sounds like a bit of a get out on my part, but the fact is that different engines are different and they're set up differently, and some can and some cannot tolerate different fuel specifications. So you should always check and see what they say your car is good for. Some elderly engines are not going to be very happy with the different specs of fuel. More modern engines are a lot happier on anything that burns. So check your guidance from your manufacturer, which will be in the vehicle handbook, or look it up online and see what particular fuel specification can my car tolerate and can adjust itself to run okay using.
All right, thank you so much, Polo. So Chris in Randburg, hi.
Chris, I've got a question about these magic light bulbs that you get. You plug them in, and then if the power goes off and the switch is switched on, it automatically brings in a lower-powered battery light. And you can obviously then, if the power is on, you can switch the lamp on and off by operating the switch in the power cord. With me so far?
Yeah.
Okay, right. Now, if you take the plug out of the socket, then the emergency light will come on. And now you can operate the switch in the disconnected power lead, and it will still switch the bulb on or off. How on earth can the bulb know when there's no circuit closed there? Because, you're holding the plug in your left hand and the switch to the lamp in your right hand, and you can switch the emergency bulb on and off. And I am totally baffled as to how it knows whether the switch in this sort of undisconnected line is open or closed. Have you got any ideas?
Well, let's think this through. If you have a light that can sense when there's an interruption of the main supply, then it must be feeling the voltage across the neutral and the live supply line to the light. It must know what the switch is doing, because otherwise every time you switched it off intentionally, it would accidentally flick on the emergency light and you'd never be able to turn the light off. So there therefore must be a process by which it can sense whether the switch is open or closed, and also whether there is live mains voltage supply across that open or closed switch. So therefore there has to be some circuitry in your emergency light that is sampling the supply voltage and also can tell whether or not that's open circuit. That's not too difficult to do, and I suspect that's how they're doing it, with a voltage registration across the live and neutral line. And I hope if there are any electricians listening, they can confirm or refute whether we're right. But there must therefore be something registering what is the voltage across the line. Is it an open line, in other words, switch open, or a closed line, switch closed? And if it sees the mains voltage adjust accordingly, then it will know that this is intentionally a light off situation, don't turn on the emergency light, or the main switch is closed, there should be live line there, there's no live voltage there, therefore it must be a power interruption, turn on the emergency light.
Thank you so much, Chris, for that call. Go to Patrick in Roodepoort. Hi, Patrick.
Hi, Kilebogile. How are you?
Good, thanks, and you?
I'm good, thank you. I've got a question for Prof. Chris. I just want to know, how come other people, it's easy for them to learn a language, whilst others it's so difficult? In my case, it's so difficult for me to learn the English language. I've been learning the English since I was 5 years old. Even today, I can't speak English properly. But my kids, younger than me, they are so fluent in English. I just want to know, how come, it's so easy for other people to learn the language. Maybe you can explain also the issue with an IQ, why other people have a high IQ like him and others don't.
All right.
So maybe if you can explain that to me. Thank you so much, Kilebogile. I'll listen on the radio.
Thanks, Patrick in Roodepoort.
Thank you, Patrick. Well, let's take the IQ question first, because this is an interesting one in the sense that, to an extent, some of your intelligence is born into you. We think, and psychologists estimate, that about half of what we call intelligence is an inherited trait. So if you have bright parents, you're likely to have a bright kid, irrespective of the environment. But the other 50% is down to the environment, the so-called nurture. So this is the nature versus nurture debate. Nurture is what you're born with. Nature's what you're born with. Nurture's the environment you grow up in. And if the environment is a propitious, supportive, encouraging, forward-thinking one, you are more likely to manifest your skills and flourish, aren't you? That stands to reason. So we think that what we call IQ and intelligence really is half what you're born with and half what you do with it. In terms of the other question, which is language acquisition, this is something which universally we all find easy to do when we're small and much harder to do when we're older. Language is one of the most demanding things that we have to master as humans, because it uses so much of our brain and so many different aspects of how our brains work. We're using our ears and auditory decoding to listen to sounds. We're connecting those to a lexicon or dictionary of words in our brains that we interpret and therefore work out the meaning of. And we're connecting that in turn to regions of our brain that can work out what we want to say using that dictionary of words. And we're then connecting that in turn to regions of our brain that have to make the very complicated, extremely precisely timed sequences of movements to speak the language. So all these things are very demanding cognitively, which is why it takes a long time to do it. But we learn everything that we learn much easier when we're younger and smaller than when we're older. And this is probably an evolutionary payoff. You don't want to very quickly unlearn something, so your brain has a loaded dice in the sense that it learns easily when you're young, but then fixes those patterns for when you're older, so you don't have to keep on relearning what you keep forgetting. Patterns ingrained into you stay with you. So it's a kind of payoff that things you learn when you're little then become lifelong lessons that stay with you. And in the grand scheme of things, that's beneficial. But when you're trying to learn a new language as an adult, this whole adage of you can't teach an old dog new tricks, it's never been truer.
All right, let's go to Lisette in Soweto. Hi.
Thank you so much for receiving my call. I want to know if what actually does the space has the end, like an edge, and if it does have what you call an end, what is beyond the space? Is it something touchable? Is it something gaseous or solid?
All right.
This
Doctor?
is the hard one, isn't it? What's at the end of the universe? And as far as we know, the universe is everything, and the universe is growing. Therefore, everything is growing. And the universe is everything, therefore it's not growing into anything. And if you got to the edge of it, you wouldn't be able to reach the edge of it because it would be growing away from you faster than you could go. Because as far as we can tell, the universe is growing away so fast that if you did get to the edge, you wouldn't be at the edge anymore by the time you got there, if that makes sense. So the universe is a bubble blowing up, and it's blowing up incredibly fast, and and as it gets older, it grows faster. So its rate of expansion is accelerating. But what would happen if you got to the edge of it? Well, apart from the fact you'd see more universe spreading out in front of you as it makes more universe, we don't know what you would find there. If you could travel ridiculously fast and get to the edge, would you then go around in a circle? Physicists don't really know what shape the universe is. They're pretty sure it's a sort of flat shape rather than a saddle or a ball, but we don't actually know what would happen if you did keep on going very, very fast in any one direction. Would you come back on yourself and back to where you started? We don't know. We don't think so, but we're not sure.
All right, thank you, Lesedi. Sam in Cosmo City, hi.
Hi, Louisa. Thank you so much, and good show as usual.
Thank you.
I've got a question for Dr. Chris. What I need to know, and what really has been, a surprise for me, is that the seawater is salty. Why the taste? Why not sweet or bitter or any other taste? Why is it salty? That is my question. Thank you so much. I'll listen from the radio.
You're welcome.
Thank you.
It's salty because there's a huge amount of salt in it. And I suppose you could turn that question into being, well, why is the sea salty? Why not fresh water? And the reason is that the water that falls on the land has evaporated in large part from the sea because the sun shines on the sea surface and gives it energy. This breaks the bonds between water molecules called hydrogen bonds that hold the liquid together and allows individual molecules of water to escape and go up as water vapour into the atmosphere. These climb in the atmosphere, driven upwards by rising air currents, that as air rises it cools, become cooler and therefore get closer together and eventually stick together and make droplets. Those droplets are pure water because when the sea evaporates water, the salty bits remain behind because there's not enough energy to drive off the salt, only to drive off the water. So the sea remains salty, fresh water makes clouds, therefore fresh water in clouds makes fresh rain. That comes down in rivers and streams and lakes as fresh water, but as it percolates through the soil, runs in rivers and makes its way back to the sea, it picks up trace amounts of salt from the land it's running through and over, and it deposits that salt back in the sea because all rivers, like all roads lead to Rome allegedly, all rivers eventually make their way to the sea. So this salt is in low concentration but nevertheless there and discharges into the sea, slowly adding more and more salt to the sea over time, and eventually you get to a steady state concentration where if you add more salt, no more will dissolve, so it forms other minerals which then precipitate out, so you get a steady state saltiness of these different minerals in the sea, and that's why the sea is salty but fresh water isn't.
Thank you so much for that question. David in Centurion, hi.
Hi, a great show, and thanks for having such an intelligent guest in studio. I just wanted to have a quick question regarding how epilepsy used to be cured back in the day. I read an article that said that the patient's two sides of the hemispheres would be divided, in that the part that connects them, which I think is a corpus callosum, would be severed, and that for some reason would cure, at least, make the epileptic fits a bit better. So my question was, why was such a procedure discontinued, and what were the effects for that patient's brain after such a procedure?
You're spot on. The early days treatment or management of epilepsy in some severe cases was a surgical one, where the corpus callosum, which is a really thick bundle of nerve fibres connecting the right and left sides of the brain, was cut. And the reason for doing that is because when people have generalised epileptic seizures, it's because one region of the brain is misbehaving and it's firing off abnormal electrical discharges, which can sometimes spread to adjacent brain areas and sometimes spread across the entire brain, causing loss of consciousness. And there were poor people who had really poorly managed epilepsy, where they were having multiple, sometimes 50 or 60 fits in a day. And you can imagine the debilitating effect this would have on their life. And so by divorcing the two hemispheres of the brain, and therefore preventing this transmission of the abnormal electrical discharges from one brain area to susceptible other brain areas, it gave some people a bit more control over their disease. But it wasn't without consequences. You can't cut a massive fibre bundle in the brain without expecting there to be an effect. And in fact, this led to a Nobel Prize for a number of people. Roger Sperry was one of the scientists who studied these so-called split brain patients. And I was very fortunate because when I was at university, I did a degree in neuroscience along in the middle of my medical degree. And I worked doing my neuroscience studies for the man who had done his PhD with Roger Sperry, who studied those patients. And it led to a massive breakthrough, really, in our understanding of how the brain compartmentalises information and does various tasks in an era well ahead of us having any kind of brain scanning that would enable us to ask those sorts of questions today. And they would sit down and present to patients a picture on one side of their visual field, say a teacup, and then something else, or like a series of words, for example, on the other side. And because the brain processes language on one side and does other jobs with other bits of the brain on the other side, if you present information on your right, that's going to your left brain. And so they found that word comprehension was therefore being decoded on the left, and other things were going on the right. And so you could show people a picture of a teacup on the right side. They'd know what to do with it, but they wouldn't know what the word was. They would solve that by picking up an object and putting it from one hand into the other and showing it to themselves on the other side of their body. And that showed us how the brain was compartmentalising different jobs, but also in a normal brain trading information from one hemisphere to the other in order to give us the ability to recognise a teacup on the one side and know, using the left side of your brain, the word for teacup. So it was a big fundamental step forward. These days we have ways of dealing with brain imaging that will enable us to ask these sorts of questions. We also thankfully have very good ways to control epilepsy these days, largely because we have drugs that can stop the abnormal discharges in the brain that would have triggered those seizures in the first place. And this is, for the vast majority of people, the cure for epilepsy. But some people still need brain surgery, but we're pretty good now at finding where the abnormal bit of brain is and deactivating it so that it can't cause seizures like those ones.
And epilepsy being one of those quite sometimes scary things to witness. Interesting, though, what you're sharing about how times have changed with how the treatment is there. Dr. Chris Smith, we have run out of time. I'm looking forward to catching up with you next Monday. So sorry to all of you that didn't get through with your questions, but we do it again next Monday. It's The Naked Scientist.